Okay, good Friday morning, everyone. It's 9 a.m. and, well, a little after 9, and that means another edition of the Urban Ecology Center's Backyard Naturalist is coming your way. My name is Tim, and I will be this week's host as we go above and beyond the normal borders of your backyard. In fact, we're going to travel about a billion with a B miles from our backyards, give or take, to one of the coolest planets in the solar system. But you can see this planet from your backyard without a telescope. So cool that the best day of the week is named after it. It has over 100 moons, some of the likeliest places for life outside of Earth. Has some fantastic stories to tell. So sit back, hopefully with a warm beverage. I got a little coffee and cinnamon this morning. Sit back in front of the glow of your device as we bring you Saturn, the Lord of the Rings, the yellow ship of the king. A little bit of a stretch. Saturn is yellow. It's named after a god, but close enough. Right after, we express a gigantic show of gratitude for our subscribers. You're the best. We love you. You do, in fact, keep this journey alive for all of us. And we love everybody that's here, no matter what your situation is, no matter what you're bringing to today. We're glad you're here. And these folks are glad too, because they were participating in our relatively new program. I can still say that for a little while. Green Spaces, Familiar Faces, which is a monthly-ish journey outside of our backyards into the backyards of the greater Milwaukee area with some really cool people who like to show off their favorite green spaces to us. Speaking of Lord of the Rings, uh, the next familiar face will be Gandalf Lineback over here on March 22nd. Will take us to one of his favorite spots along the Milwaukee River on the west side of the river, not far from Riverside Park. So join us if you can, and if you'd like more details, just shoot me an email or talk to me in person or talk to me on March 22nd as we go on a fun urban adventure together. And then I would like to cite my favorite sources of information and inspiration from any of these episodes, including this one, the Stuff You Should Know podcast, the podcast that got me into podcasts, as well as Mental Floss and How Stuff Works, which are all fantastic places to get lost in, as is the planet of Saturn. So we know Saturn as one of the 9 planets if you were born in the 20th century, or 8 planets if you're a millennial. It is the showed in the mnemonic about my educated mother. Showed. And I think if you were to do a word association or, oh, it's snowing, or draw a planet, I think when you want to distinguish what a difference between a planet and a star, you often will draw rings around the planet. So you're often drawing Saturn, even though it's not the only planet with the rings, but it's the most, distinguished and well-known and iconic ringed planet. Um, and so then it's not a star or a moon. It, like I said, it's not the only planet with rings, and Jupiter, Uranus, and Neptune are the planets that, along with Saturn, make up the gas giants in the outer reaches of the solar system. They all have some sort of ring system, but none currently as showy or as bright or as prominent as the rings of Saturn. If you ever get a chance to look at Saturn through a telescope, and I remember the first time my dad showed me the planet Saturn through a telescope, and I've heard this from others, it just looks not real. It looks fake. It looks like you are looking at somebody just put in, slapped a picture on that telescope. It just does not look real because it's so perfect with that ring system and it's so prominent. Um, so but it is real. It is, and you can see much better pictures than this, but there is something to be said for seeing it with your own eyes, with even just a basic backyard telescope. It's just the amazement factor explodes. And the fact that you can make out the rings on an object that is a billion miles away certainly says something about how large the planet and the rings are, if nothing else. And so, uh, again, even your backyard inexpensive telescope is going to give you a much clearer view than what Galileo saw 400 years ago in 1610 through his rudimentary telescope, good at the time. He couldn't make out the rings, but he did notice that the planet had bulges or handles, like on a, teapot or something. And at one point, he hypothesized that maybe it was a three-body system, like a trinary planet. But again, at that time, it was limited by the optics. And then it wasn't for another 50 years that Christian Huygens, with much improved optics, hypothesized that the bulges were rings that did not touch the planet. So that's what you go on record um, as the discoverers or whatever. But it was long before either of these gentlemen that we documented the existence of Saturn. So it was known. It's one of the planets. It's one of the wanderers that you can see with your naked eye. And this is a Sumerian cylinder seal that has the planet Saturn on it. And to some scholars, they think that the Saturn they depicted here does have rings. So maybe it is crediting Galileo a bit prematurely, but I'll leave that to the scholars to decide. And the world's oldest astronomy book, or the world's oldest known astronomy book, the Surya Siddhata, is from India. And in this book, based on what they knew back in the fourth century, they're talking about the 300s, this book estimates the diameter of Saturn at 73,580 miles. Again, this is the fourth century. Compare that to what we currently think of Saturn's, what estimate Saturn's diameter as, and that is pretty amazing. It's about 1,000 miles off, incredibly accurate back in the 300s. That hasn't changed that much until today. So you're just constantly blown away by all of the amazing astronomical knowledge that came from cultures around the world in all parts of the world a long time ago. The English name Saturn is named for the god of agriculture and harvest, and is, like I said, the name behind Saturday. And I'd love to do this with you all again sometime. I learned this it's kind of an exercise that I learned, I think, from the UWM planetarium. But if you write down in order from fastest to slowest, the objects that move across our horizon that aren't fixed, the wanderers, so that would be the planets plus the sun plus the moon. If you write down in order how fast it takes them to cross the sky, and then you go back to a belief that each of those wanderers is a god, and each of those gods is ruling over an hour. So you start at Sunday morning at midnight, and then 1, 2, 3, 4, 5. You find that each day is brought in by a new god. And so that's why we have in order the sun, um, the sun, the moon, then you go to Mars, then you go back to Mercury, then you go to Jupiter, then you go to Venus, and then you go to Saturn. So it's a really fun kind of what do you call it? Like a cocktail napkin activity to show that. Um, but in any case, Saturn is really big. It's not the biggest planet, but it's really big. To to go to one of Vic Vargo's favorite exercises, if the Earth, I'm not gonna put the Earth at the size of a pea. I'm gonna put it the size of a nickel because this is a little easier. If the Earth were the size of a nickel, not flat, according to most, then Saturn would be about the size of a volleyball. So those are two easily things you could compare. It's about 10 times wider than the Earth. The Earth has a diameter of about 25,000 miles at the equator. Saturn is about 10 times that at 227,000 miles. So a really big planet. And you probably have heard this one before too, that if Saturn were in an ocean that was big enough to hold it, it would float because it's low density as a planet, as a gas giant. So it would float on water. There's no solid crust or surface to the planet itself. It is very far away from the sun, about 886 million miles. And so at that distance, it gets 1.2% of the sunlight that we get on Earth. The light that takes 8 minutes to get to our planet takes 80 minutes to get to Saturn from the sun. And so, as you'd expect, it is very cold. At the surface, or the surface of the horizon, it's about negative 220 degrees Fahrenheit, which is indeed very cold, but it's not as cold as you would expect from an object that is that far away, because Saturn does generate quite a bit of its own internal heat, as do a lot of the bigger planets and moons. It takes about 30 years for Saturn. I'll go back here. It takes about 30 years for Saturn to orbit the sun. So if I were born on Saturn, I would still be a few years from my second birthday. But then on the flip side, the rotation of Saturn around its axis is very fast. In fact, it's the second fastest planet in regards to rotation around its axis in the solar system after Jupiter. So for reference, the Earth spins at about 1,000 miles per hour to give us our 24-hour day. Saturn spins at 23,000 miles an hour, 1,000, 23,000 miles per hour. So a day on Saturn is much shorter than an Earth day. It's about 10 hours, 10 Earth hours. The atmosphere of Saturn is about 75% hydrogen and 25% helium. The planet itself is mostly helium. If you were to break in, past the surface of the planet and descend about 40 miles, you would reach a liquid layer, an ocean of hydrogen, a liquid hydrogen. And this is notable because we can make liquid hydrogen here on Earth, but for us to do that, we have to get it to negative 423 degrees Fahrenheit. So it takes cold and pressure to turn hydrogen from a gas to liquid. And on Saturn, it doesn't even need that cold. The pressure is so great that the hydrogen just liquefies immediately. Doesn't even need that cold. So if you were able to kind of parachute in past that outer helium gas layer, you'd reach this liquid ocean hydrogen. And then if you put on your suit and you go diving into that ocean, you would eventually reach what's called the liquid metallic hydrogen, which is so compressed that the liquid acts like a metal. And, just as I'm sure we can all relate to this, if you think of an atom and the electrons that are very far from the center of that atom that are, orbiting around it, it is so compressed in this liquid metallic hydrogen that the electrons are actually all touching each other. It's so compact that the electrons can't do what they need to do, which makes it act like a metal and conduct electricity and so if you were able to make your way somehow through that metallic layer, then you would reach the core, and the core is compressed molten iron. Looks small in this diagram, but you could fit 55 Earths in that the core of Saturn. It's about 15,000 degrees Fahrenheit, and that is hotter than the surface of the sun. The core of the sun, remember, is 27 million degrees, but the core of Saturn is hotter than the surface of the sun. So that's 15,000 degrees. That's pretty hot. Um, there is some debate. We're not totally sure if that molten core is solid. Some postulate that it's slushy because in addition to iron, it has gas and rock and even ice. Somehow ice is able to survive in that extremely compressed hot uh, core. Not sure how, but there is good evidence that it does. Uh, so then, how did Saturn originate? The standard theory, the standard planetary theory that's been around for a long time is called the core accretion model, and it's not just for Saturn, it's for all the planets. It says, when a star like our sun forms out of dust and gas, there's a lot of extra external debris that begins to swirl around the star, forming a disk, and then the material in that disk accretes through collisions and gravitational pull, and the accretions start to get bigger. And as the accretions get bigger, their gravitational pull increases, so they start to grow, bringing more things in, and then form those nice spheroid, oblong spheroid planets that look so nice. And according to this theory, the closer these accretions are to the sun, the more they're likely to interact with and attract the heavy stuff like the iron and nickel, which would really explain why the closest planets to our sun, Mercury, Venus, Earth, and Mars, are the rocky planets. But according to this theory, even the outer gas planet giants begin with that rocky core. A competing theory put forth by Alan Boss is that gas giants don't need that rocky core of iron and nickel, which, maybe to most of us isn't that big of a deal, but to astrophysicists, they go nuts over this stuff. So, according to this new theory, that the lighter, it's just gas, and the lighter gases become so compressed that they exert a gravitational pull that brings in gas and dust from a much larger area. So, but regardless of how they're formed, it formed, and we've got this beautiful planet, gas giant. It's a very stormy planet. There's and just like here on Earth, the storms, the more violent storms are caused by differences in temperature and pressure. And so when you have a very, very hot inner core and a very, very cold, icy outer atmosphere, you get a lot of fuel for some massive storms, 1,000-mile-an-hour winds. And there was one individual storm on Jupiter that uh, actually stretched across the entire planet. So if you think of like, we'll get a big storm system that'll pretty much take up the whole North America. You can see them, but this one went all the way around the planet, and one individual storm on Jupiter could last for years, and then it might peter out, and you might have a couple of years before the next storm comes, and then that next storm could last also for years. In 2010, the Cassini probe photographed a single, I'm sorry, it photographed this hexagon uh, that I'm sorry, this is Voyager 2 that photographed this hexagon in 1981. Again, and then later seen again by Cassini. So it's been there at least since 1981 to 2010. It was still there the last time we checked. And so they're kind of thinking this might be, rather than a storm that comes and goes, this might be more of a permanent feature, kind of like, our circumpolar currents and things like that. This just might be there forever, or at least in current conditions is a feature. And it's very strange that it forms that hexagon pattern. It's really almost a perfect hexagon. You think of it is flatter. All the planets that are rotating are going to be flatter at the poles and more bulgy in the center. So maybe that has something to do with it. At the center, there's 500-mile-an-hour winds. And again, this is a planet that's rotating very fast. So I don't know, maybe it's got some spirograph kind of thing going on. But a very cool system. And then we move to those rings. So just an absolutely strange and brilliant and beautiful and mesmerizing and wonderful feature for any planet to have. This is the characteristic that makes you think it's too strange and perfect to believe, again, when you see them in a telescope. So there's a lot of questions about the rings. I think maybe the easiest one that we've been able to figure out is what they're made of. And it's about 95% ice crystals and about 5% rock. The size of each individual particle in those rings ranges from the size of a grain of sand to the size of a large boulder. It is incredibly wide. Um, and I love how this is a Cassini image showing the sun casting a shadow on the rings. It reminds you that's a normal planet with sunrises and sunsets and day and night. But the rings are incredibly wide. They reach out 175,000 miles from the upper atmosphere, about 7,000 times the diameter of the planet. And it's a wide planet. These rings are incredibly wide. So again, the fact that you can see them from a telescope separate from the planet, it's very wide, almost impossibly wide to think about. So, but for as wide as they are, they're also incredibly thin. There's 30 to 60 units thick. I say units because you could be thinking, oh, if that's miles, 30 to 60 miles, that's really, really thin. But it's not miles, it's feet. 30 to 60 feet thick. So hundreds of thousands of miles wide, 30 to 60 feet thick. So this is a Hubble image, and there are certainly periods when you would look at it, and if the ring if you don't get a good tilt based on what you're looking from the Earth, you don't see the rings. They can disappear. Um, so I don't know. There's probably not a good analogy, but it'd be like playing frisbee with a disc that was made, the frisbee made out of like super thin paper. I don't know, but it's very wide, very thin. And one of the reasons why it's so fun to see Saturn is because those rings are at a tilt. So you usually do get to see the rings because the planet is tilted. Tilted very similarly to how Earth is tilted. If it weren't tilted, we might never see those rings relative to the orbit plane. But the Earth is tilted about 23 degrees. That gives us our seasons. Saturn is tilted almost the same amount, a little more. It's at 27 degrees, so they have just slightly more pronounced seasons, relatively speaking. Uh, since it takes about 30 years for Saturn to travel around the sun, this means that each season, if we look at according to our seasons, would be 7 years long. So 7 year summer, 7 year spring, 7 year fall, 7 year winter. I wouldn't mind a 7 year long fall, but if you're in your least favorite season, you got a long time to wait for the next season. The one of the things that early astronomers noted after it took a while to know that Saturn did have those rings, that those bulges were actually rings, is that it's more than one set of rings. There's a distinct set of rings. There's gaps between the rings, those kind of dark stripes. Some rings are brighter, some are more dense. And our wonderful human ingenuity gave these beautiful names to each ring: A, B, C, D, E, F, G. They were named based on the order in which we discovered them, right? But they're not based on how close they are to the planet. So it's like watching your Marvel universe in release order rather than timeline order. So from the planet's surface, it's D, then C, then B, then A, then F, then G, then E. There are more than seven sets of ring, but these represent the ones that we can kind of put in our nice, neat human boxes. So the largest gap, the one you see most easily, is the big one in the middle there. It's called the Cassini division in between the A and B rings. And that distance, this is a fun one. That distance between those two rings is about the same as the distance between the east and west coast of the United States. So on the podcast, Josh noted it'd be about the one end of ring A would be Seattle and the other end of ring B would be Boston. And the Cassini division is caused by an interaction with Mimas or the Death Star. One of this is so again, Saturn has 100 plus moons, and uh, if you were a particle that was originally in that Cassini division, that gap, and remember each of those particles is orbiting the planet. Every twice in every orbit, you pass close to this moon Mimas, and every time you get close to that moon, you get a slight deflection from its gravitational pull. Every time you do that, you're getting a progressively stronger pull. You're getting closer and closer, and then eventually you're just pulled right out of orbit towards Mimas. And so essentially, as Mimas it's the closest of the moons, Mimas is basically acting like a giant magnet or a giant vacuum cleaner, and as it goes, it pulls its gravitational force is most strongly, pulling that area in the Cassini division, and then it gets less and less, progressively less, influencing the other rings or the other parts of the ring. So basically, Mimas just kind of cleared out that middle division called the Cassini division. Each gap in the ring, therefore, represents a point of gravitational pull out of the ring by something like a moon. And so we know what the rings are made of. We have an idea about the gaps in question, but we still today don't have a solid answer as to why they are there and for how long they've been there. As is the case with a lot of astronomical questions, there are several competing theories. The standard theory is the most basic, that the rings were formed when the planet formed. So, the sun formed, eventually all that dust became planets. One of those planets had its own ring of dust that is, maybe been forming moons and other things. So if that's the case, then these rings are 4.6 billion years old, which is, when our solar system and Saturn came into being. But in 1986, an astronomer named, that's really recently, Jack Connernet, proposed a theory that the rings that we see today are way younger than the planet Saturn. So our probes and our missions to Saturn found that there is something in Saturn called ring rain, which is when particles in the rings become charged by solar winds, like our aurora here on Earth. And when they do, they become more attracted by the gravitational pull of Saturn itself, and they follow that magnetosphere, they follow those magnetic field lines down into the planet. So essentially, these rings are raining down into the planet, and he calculated the rate of ring rain. And based on current conditions, he hypothesized that this current set of rings cannot be more than about 100 million years old. And according to his calculations, in another 100 million years, these rings of Saturn will be completely gone. And Saturn will just look like any other round spherical planet through a telescope, which which means that according to this theory, the rings around Saturn are dynamic. They're forming, they're disappearing, they're growing, they're shrinking, and they've probably been doing this since the beginning. In fact, all of the gas giant planets, those rings are probably also in this dynamic state. So, you look at the four ring systems now, Saturn is the most prominent. But if you were to return to Earth, in a few 100 million years, we might be saying the same thing about Jupiter. Like Jupiter, its rings are the most iconic ringed planet. So it's interesting to think that all four of those gas giants have rings to varying degrees, but at some point in time, we would have looked at Saturn and not seen any. Another competing theory is that the rings were formed when, again, a bunch of moons. They have a lot of moons, and if some of those moons collide at some point, they could create a massive debris field that spreads out in this pattern. It is thought that the E ring in particular might outlive the others because it is formed by saltwater volcanoes that are currently and constantly erupting from the moon Enceladus. And so that particular ring might get a source, not just kind of being lost by rain. Another theory is that because the rings are mostly ice, they were formed when a comet collided with one of Saturn's moons, spreading the ice out in a thick layer, especially since the rings are mostly ice. So quite a few competing theories, and new rings are continuing to be discovered. In 2009, they found a new ring with the Spitzer Space Telescope, and this particular ring or ring gap is likely formed by the orbit of the moon Phoebe, very faint. So, and what again, we're really just with more and more evidence, there's more and more support that the rings of Saturn are dynamic, they're changing, they're reshaping. It'd be really fun to see this in like a time lapse video of the rings if this is the case forming and disappearing, but you'd have to set your camera phone to like tens of millions of years to be able to enjoy it. But on a slow geological scale, these rings are shifting, growing, disappearing, moving. So, Saturn is known for its rings, Jupiter is known for its moons now, but also Saturn is not too shabby when it comes to the moon department. There's 100, at least 150 known moons, and new ones are being discovered all the time. And this blew my mind. When we started our first Backyard Naturalist, if I were to have done this program back in 2022, even a couple of years into the Backyard Naturalist, I would have said we've got 62 moons in Saturn. I'm sorry. There were about 90 moons in Saturn because in 2023, just 2 years ago, the International Astronomical Union added 62 more moons orbiting outside the ring system of Saturn. So I don't know why they wait and do them all at once or whatever, but uh, they basically almost doubled the number of moons that we thought there were just a few years ago. So this we mentioned Mimas. So Mimas is the moon that creates the Cassini division. It's also the closest moon to Saturn's atmosphere, and this is you can see it on this image that Mimas is the biggest and closest of the moons. Well, not it's not the biggest moon, but it's that big one that's close by. Um, the the it creates so this is the one that creates the Cassini division. It's actually half. This blows my mind too. It is half the distance to Jupiter as our moon is to Earth. Our moon is 237,000 miles from Earth. Mimas is about 115,000 miles to Saturn. So you can see it's very close. You can see how it would influence so much those rings because it's really in the rings. It's also extremely fast. It's traveling at 32,000 miles an hour. It orbits that huge planet of Saturn in 22 hours. Our moon takes a month. This one, and we've got a pretty small planet. Uh, this moon orbits in less than our day. So it takes our moon a month to go around Earth, which means if Saturn months were based on that moon, a month would be less than a day. I guess that's kind of confusing. But anyway, it's a close moon. The most famous moon, though, is Titan. So this is Titan. It's large enough to hold an atmosphere, which is pretty rare among planetary moons. The surface of Titan is full of mountains made of ice. The oceans are made of ethane and liquid methane. The atmosphere itself is similar to Earth. It's nitrogen based. And the main difference has to do with air pressure, which is 150% stronger at sea level than on Earth. So if you were able to go hang out on Titan, it'd be pretty cool because it's such a thick, dense atmosphere that when rain falls, it falls in slow motion. When we go outside, it's raining, our rain's falling at 20 miles an hour. If you were to go outside on Titan, the rain falls at 3.5 miles per hour, which is super trippy. Like, I was at a baseball game once when it was the Cleveland Indians, the Cleveland Guardians, were snowed out of their stadium and they moved. They had to kind of borrow Miller Park, and I went, so it's full of all these Cleveland fans. When they did the wave in slow motion, and it was super trippy. It's like that's not how the wave is supposed to be. The wave's supposed to go around the stadium pretty fast, and then seeing it in slow motion just like messed with my mind. I imagine that's got to be exactly the same feeling as if you were to go out and Titan and see rain falling in slow motion. And again, because it's an extremely dense atmosphere, it it also allows sound to travel quickly. So, good luck trying to like whisper something to your friend. Everybody would hear it. And so when you're in that stadium on Titan doing the wave, you could talk to somebody on the other side of that stadium, tell them they're doing it wrong, but you wouldn't have to raise your voice. They could hear you, which would probably be really bad if you had tens of thousands of people all talking at once. Um, you can kind of get this here on Earth, in our dense atmosphere, our humid atmosphere, we notice it a little bit, like, you know, um, uh, baseballs travel farther in certain conditions. We can notice sound traveling farther if and I remember this clearly. I was canoeing on a lake with a friend, and Chad Tomac, who works at the Urban Ecology Center, was on a dock. I think he was journaling. It was in the morning, and I don't remember who I was with. I started talking to, I was like, boy, like the sound is traveling crazy. I wonder if Chad can hear us. And without even like looking up from his book, and he was pretty far away, he said, "Yep, I can hear you." So the sound that day on that morning, that foggy morning on that lake, sound was traveling so well over the lake, right? I think that the sound waves are bouncing off of each other and just really focused. But if you were on the moon Titan, your voice would travel very far, which would be, I'm sure, great at sometimes, but probably really awful at other times. Um, Before you decide to say like, sign up for our eco travel trip there, and see this really cool trippy rain and sound, it is important to know that the average temperature on the surface of Titan is minus 290 degrees Fahrenheit. There are liquid salt oceans that are 50 meters below the surface. There are hydrocarbons on the surface and down further. So you think about how life likely formed on Earth. They have organic, they have organic materials. They have liquid salt water, which is why the moons of Saturn are some of the most intriguing places for us to explore to see if life exists within our solar system outside of the Earth. And quickly back to this. So this is the moon Enceladus. This is the one that spews ice volcanoes. It's much smaller than Titan, and it's about the size of Arizona. But our probes have sampled water. It has a saltwater ocean under the crust that is both protected from space and heated from the core. So the ice volcanoes indicate that there's likely geysers and hydrothermal vents. So now you think about the potential formation of life. You've got a warm, protected saltwater ocean. You've got hydrocarbons, the building blocks of life, and you have hydrothermal vents. So when you look at how we think life formed on Earth, these are the exact materials. So the conditions to produce life, probably the highest likelihood of there being life outside of Earth. So, and when they send these probes to these places where it's possible, they got to be really careful about not contaminating with life from our planet. So making sure they don't, tardigrades aboard or whatever. Which is why when Cassini was done, they kind of sent it on a suicidal joyride right into the planet. And we're gonna watch a little video version of this, or artist's conception of it after the recording stops. Um, In 2028, this one's for Maggie, NASA is hoping to launch this Disney-inspired probe called Dragonfly. It's going to go to Titan and land on Titan. It'll take 6 years to get there. Hopefully, we're alive and civilization is still going on then, but that will be a fun NASA mission to follow, hopefully. So that's Saturn, and we are actually approaching one of the best times to view Saturn this fall when Saturn will be opposite the sun from Earth. So we're going to get really good nighttime views of the planet and the rings. So thank you for joining me today. This is such a crazy cool planet, and I hope you enjoyed this, and we'll see you next week.